Okay, and so now in this video, let's prove. Let's try to. If you have seen the previous video, that the goal of the rest of several videos, prove this primitive roots theorem. Basically, said that this CM cross is a cyclic group. If M is 2 for PK2 group. Okay, and so I will first do the simple case. So let me just introduce the structure theory. Structure one. So this is a very simple one, but already like a little bit non-trivial. So this theorem tell me that if uh, Mn is coprime to each other, so basically the GCD of Mn is 1, and then let's say Mn both greater than 2, then Z of M times N cross has no primitive roots. No primitive roots. Basically, what this say is that this group is never cyclic. Okay, so this is the first no-go theorem that I proved in this video, which is should be very simple. And so there's a simple lemma that let's say there's a simple lemma that we can do, right? So first, notice that 5M is even for any, let's say M greater than 2. Okay. And yeah. So why this is the case, right? So notice that I can always write M is at 2 to the D times X. So X is prime. So X is R prime. So 5M will be just 5 2 to the D times 5X. Notice that 5 is multiplicative. So this will be 2 to the D minus 1 times 5X. So in order for this guy to be odd, right? If this guy is odd, then means that D minus 1 must be equal to 0. And also 5x need to be 1, right? Because for each odd number, that the 5x is already even by the multiplicative by definition. Okay, so in this case m must equal to 2. Okay, because d can only be 1, and the x must be 5x 1, which x is 1. Okay. Oh, okay. So now we can prove the structure theory. So I can get K to be the least common divisor, sorry, least common multiple of 5M and 5N. And by definition, this is greater than 2, right? It's greater or equal to 2 because these are all even. And this is also strictly less than 5M times 5N because they have the common divisor, right? So the least multiple cannot be the product of them. And by multiplicative, this guy must be 5Mn. So if I see the any element inside this, let's say I take any element that's written as A and B, the AB tuple, each A is inside the right. Okay. So notice that this now this holds as a group. I should say isomorphism as a ring. Okay. Because Mn are coprime. So let's say I take any tuple AB inside this, then this already the Euler theorem tell me that A of phi m is 1 m, and the B of phi n is 1 mod n. Okay, so if I just do the k power, so let's say sorry, not k power, I do a to the k, which is 1 mod m, because k is the least multiple of phi m and phi n, and the b's k is 1 mod n. Okay, so that means that k is the order, right? K is the order. Okay, but k is less than phi of mn. Okay, so that means that every element inside this group has only order up to k, which is less than phi of m times phi of n. So this means that there's no primitive roots. Primitive roots. So let me see, this means that this group can never be cyclic. Okay. So this is a simple structure theory. Okay, and so okay, so that so right, so since m is greater than 2 and is greater than 2 is and it's coprime, then this can never be there's no primitive roots, right? There's no primitive roots. Okay, so it's obvious that it can only be like m is odd prime power, so it's either uh m is 2 and n is some odd prime power, right? Otherwise, that you can use this theorem and show that there's no primitive roots. Okay, or m is 1, that n is some r prime power. R prime power. Okay, so the rest, the non-trivial part is to show that this is the only case. Then if you use theorem, the remaining part is always has a primitive roots. Okay. Oh, by the way, it's not true. You still need to show that 2 to the k has no primitive roots. Okay, so you need to show that the z2 to the k cross has when k greater than 3 has no primitive roots, and we already showed that k equals to 3 is the case. Okay, so since you use the structure theorem, so rest is be just checking 3 part. The 2 to the k has no primitive roots, prime to the k has a primitive roots, 2 to the prime to the k is primitive roots. Basically, this is the rest. Okay, and so see you guys next videos.